This video covers limiting reagents and percent yields for page 65 of the lab manual. In this experiment, we will discuss a synthesis and also a way to judge how effective we were in obtaining the product of that synthesis.
I'm going to give you a so-called limit. All right? Not more than 1.25. Not less than 1.15. In other words, positive, negative 5, 0.05. Same thing right here. As long as it's below 2.05 or 1.95, you're okay, all right? Because it's a limiting reagent, we want 1 always. What I remember, it is a solid material, so we're not going to use our finger, right? And then we have to use something called a scoopler, and then 1.10. Okay, so let's do it. Okay, so record. Oh, that's too much. Goodness. Two, 5, that's a little bit too much. I'm going to. All right. Oh no, I want to. A little more. A little more. All right, very good. 1.22. 5 milliliters, so about, meaning not exact. And then, all right, just pour in, all right? Don't do anything, just leave on the side, all right? Leave on the side. And then now use the larger of the two. Weight your potassium oxalate. All right, 1.96, beautiful.
Once you have weighed the potassium oxalate monohydrate, add 10 ml of deionized water
into
this.
Okay,
Stir
so
until
now,
the solid has dissolved.
ladies and gentlemen,
and then
please
place
return
both
back
beakers on
to
the
our
hot plate.
page
Heat the solution to
65.
about 90
all right?
degrees.
We're not Yeah, it's warming up, all right? So now we're trying to make two solutions, two aqueous solutions. Okay, when water being heated up, what happens? It will become to a point called the boiling point, and then steam come out. So if you hold your beaker this way, and then the steam will hit your palm, and so you are going to get burned, heat burned, all right? So the way to do it is hold the rim, and then shake like this. And then that will avoid any kind of heat injury, all right? So now you can see very clearly, all right? Very clearly. I'm going to use a white background later on. You can see that very easily, all right? Now, all the solids are gone. Now, describe our first solution on page 65. And then, all the white solids also are gone. Describe our second solution on page 66. So the first solution should be described as a clear sky blue. Second one, clear colorless. All right, very good. So now just place back those two solutions on hot plate. Wait until them start boiling. All right, the key success for today's lab is number one, both solutions must be at the boiling stage. Second one is the direction, which one goes into which. It is blue into colorless. All right, so just wait. And then periodically give a gentle stir. Periodically give a gentle stir. You can see now which absolutely it's correct because it has a less solution. It's only 5. It only contains 5 milliliter water. So we're going to place on the side, all right? And then in the middle, it's our 10 milliliter, double the size. So it takes a little longer to start, okay? Clear, sky blue, clear, colorless. Ooh. No longer colorless, no longer sky blue, but it is a royal blue solution, all right? Royal blue solution. It is a solution, it's nothing else. Then when it's done, and then place it on the cold surface of our lab, and now we're done. All right, very good.
Reactions in chemistry occurs in moles. We use the molecular formula to calculate the molecular weight of the reagent first, which is in grams per mole, and then its corresponding moles. We do that for all the starting materials.
Waters are part of the molecule, so you must count those 5 crystal waters.
Once the product crystallizes, we will isolate the sample by filtration.
Now, come to this so-called filtration setups. This is what we call the O-ring. Why it's O-ring? Because it looks like a letter O. That's why it's called the O-ring, all right? And this is what we call the either titration stand or O-ring stand. It's called the stand, all right? You place on top, and then remember, anything touched to our stand can be moved up, down, left, and right. All right, that goes to anything attached to it. And later on, titration, and later on, reaction, so on and so forth. Use your clean finger, fold your filter paper once, this way, or second time, this way. Now you made one pouch and two pouches. Use one of the pouches, all right? That's it. Place it inside like so, all right? Which is page 67, all right? That's it. So now we have a dirty beaker right here, all right? Move it down and touch the wall on the side, all right? And stir the pot as much as possible, and then use one finger to hold your filter paper down in place, and then simply pour everything in. All right, no matter how skilled, how much you do, you can see there's some residue left right there. This is the time we introduce a new piece of instrument. It's called rubber plates. And then very gently take all the blue crystals from your container, which is a beaker, into it. All right, that will be it. And then we generate our first waste. Pour it into our waste, which is labeled. All right, now you are asked to use a 4 milliliter ethanol, about. So in other words, you don't have to really measure that closely. So about 4 milliliter, right? That's it. Okay, and then the way you use any kind of a solvent and include water to wash your product, the way to do it is slowly, 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 slowly turn your container, and then just like it, do its own work. Slowly make the turn, and then, all right. Now, if you may, please pay attention to the long neck filter. You can see some white solid being washed out. All right, just keep in mind what that is. All right, and some of the professors would like to use cold water to wash first, and then why? Now you are asked, number one, pour your second wash out. You can see still blue, but much less blue. All right, into our solution. And keep this in mind, because later on I'm going to ask you questions. Your professor will ask you questions. You do a same thing, all right? Use a clean filter paper. You fill once and then twice.